Hi everyone, in this video I want to show you my code to model and simulate a wireless communication system using Matlab. Okay, so let's start right away. Now, any communication system is just basically three parts. You have a transmitter and you have a channel through which you send your message, and you also have a receiver. Okay, so in each part of this three basic units, there is some signal processing, okay, like modulation, like upsampling, and at the other end you do the opposite, so you do a lot of stuff actually, but like downsampling and demodulation to get the original voice, okay. So in this code, I will show you how to model this on Matlab, and you can test this using two input sound signals, which are made as a dot wave files. Okay. Okay. Uh, so first, before we begin, there is also a small code that you can use to create message by your voice. Okay, just recording for your voice to create dot wave sounds. Now I have this dot wave examples from Matlab, so they are not recorded, but you can listen to this. Okay, this is one. This is another one. Okay. Now I will make a third one by this code, which is create message, okay, by my voice. So let's see this one first. Test of recording. Okay, so that's like a test, okay, for this part. Now let's give it a name. Let's call it, I don't know, message. And here you go. You should have, yes, here you go. You have message input. Okay, this is the first one, which is a small code. Now to the main code, which is the simulation of the system itself. Now in this project, what I use is what is known as quadrature amplitude modulation. Now this means that what you do is that you send two messages, or actually theoretically you can do more, but here you send two messages on the same carrier, okay, but using different angle. One of them gonna be sine and the other will be sine. So you will also have a detailed report, okay, you will find it in the description with the code that will go through everything regarding the idea and the way the message are sent to the other end, okay. But as you can see, it is only one carrier. It is frequency of 100 kilohertz, okay. Of course you can change this like you want, okay. You can change this any value, but this is you have only one carrier for the tools. Okay, so let's try this out, and we will see also, we will hear the two messages, okay. So at first you will input two of this sound files as an input, and at the end you should hear the two voices, okay, after each other, and then we're gonna see the figures of the simulation, which is the spectrum of the sound signals along the way, okay. So let's try this. Let's take this one, and the message we recorded. Okay, now it's working. Okay, that's very good. So it's working fine. Now let's see the simulation results or the figures. Now this one, the first one, shows you the spectrum of the two signals, the two input signals. Okay, then they are both modulated at the same frequency, which is the carrier frequency. So that's good. Then the second part, of course, you can find all this in the report. You will also get it with the code from the description. You can see that the signal of the message is just the addition of both, so it is on the modulated carrier, okay. And then the figure, this figure shows you the demodulation. So when you demodulate your message, you get two channels, which is you re-separate the two channels again. So you get this one and this one by demodulation. Now then you remove the unwanted frequencies components by a low pass filter. Of course, you can see how all of this is implemented and simulated in the code. And here you go, you have the two message. Now to see this better, maybe you can do this. Yes, maybe we can do something like this. Okay, yep, something like this. So we can see, so we see that this one is the same as the first signal, so that's good. You have received it well. The same here, so you can see that this one is the same as this. So you completed the transmission process properly. Now the last one shows you the behavior of the low pass filter, okay, and how it works with the normalized frequency. Thank you for watching. You'll find everything in the description, the code, the report, and everything. Thank you for watching.